now we're getting into the good stuff for this chapter. So SOHCAHTOA is going to help you for the whole rest of the chapter. It keeps all the things organized. SOHCAHTOA is just an easy way to remember it because you can verbalize it, you can sound it out. The way it works out is you cut it up 3 letters at a time. The first part, S, O, and H. S is for sine, O is for opposite, H is for hypotenuse. C, A, H, the next 3 letters. C is for cosine, and then A is for adjacent, H is for hypotenuse. The last 3 letters, T, O, A. T is for tangent, O is for opposite, A is for adjacent. Because the only types of sides you have on these triangles are opposite, or adjacent, or hypotenuse. If you can get this down, this is like 80% of what you need to know, is being able to know which numbers go on top or bottom, so which sides go top or bottom, and which trig function to use. Friday we did tangent, today we're doing sine. With sine we care about the opposite and the hypotenuse. If we're looking at sine A, we're going to go from this angle, my opposite is going to be this side. My hypotenuse is going to be this side. So that's why it says A on top and C on the bottom. For the sine of B, now we're looking from the angle up here. Now my opposite is going to be the B. My hypotenuse is still going to be C. You have to know, if I tell you you're doing sine, you have to know which one's your opposite, which one's your hypotenuse, and which one not to use, which is going to be your adjacent. Right here it says find the sine of A and the sine of B as fractions and as decimals and round to 4 decimal places. So if we're doing the sine of A, from here my opposite is 6, my hypotenuse is 10. Now as a fraction I can reduce this down, it's 3/5. As a decimal it's going to be 0.6. So you're supposed to give me both answers on this. When we're doing sine B, now we're looking from this angle up here on top. My opposite is now going to be the 8. Hypotenuse is still going to be 10. If you reduce that, you're going to get 4/5. And if you put it in the calculator, you're going to get 0.8 as your decimal. Next one, over here from A, your opposite is 21, your hypotenuse is 29. That doesn't reduce, so there's already one of your fractions. If you put that in the calculator, 21 divided by 29, you get 0.7241. We have to round to the 4 decimal places because this one kept going on and on and on. For the sine of B, from this angle your opposite is 20, your hypotenuse is 29. You still can't reduce that fraction. And then in the calculator, you get 0.6896, but then that 5 makes it go up, so it's 0.6897. And then for this third one, the sine of A is going to be opposite over hypotenuse, square root of 2/2. You can't reduce that. The decimal part of that is 0.7071. For the sine of B, if you're looking from this angle up here, your opposite is this square root of 2, hypotenuse is still 2. And because it ended up being the same thing, your decimal is going to be also the same. Next section, it says find the missing length. So here's how you actually use sine. Most of the time you don't really care about this as a final answer. This is just part of the work that you use along the way. What you really care about is how do you find the length of a missing side using sine. So since you have this angle down here and you see that this is your opposite and 7 is your hypotenuse, opposite and hypotenuse is y, according to these 3 options you want to use sine. So then you go, okay, I'm using sine. The angle always goes next to the trig function, whether it's sine, cosine, or tangent. Then your opposite, because we're using sine, your opposite goes to the top and your hypotenuse goes to the bottom. Once you have this set up, we're going to do like we did on Friday. Because the variable is on the top, you're going to multiply. This 7 is going to be the number that goes in the front, and then you're going to put multiply because the variable was on the top, and then this trig function, sine, with its angle, 34, and that's what you put into your calculator. So it's 7 times sine 34 equals, and you get 12.5. here's the whole process a little bit smoother. Watch. From that angle, that's my opposite. That's my hypotenuse. Opposite and hypotenuse tells me I'm using sine. The angle is going to go next to the trig function. When I set up my fraction, I know my opposite number goes on the top and my hypotenuse goes down to the bottom. Now that I have this set up, I know that because the variable is on the top, I'm going to multiply. The number from the fraction is always going to be in the front. The sine, or the trig function, with its angle is always going to be at the end, and because the a was on the top, we're going to put a multiply sign in between there. After that, this is all calculator work, and you get 10.9. Here's a third example. From that angle, 5 is your opposite, c is your hypotenuse. That's how you know you're using sine. The angle always goes next to it, opposite goes on top, hypotenuse goes down to the bottom. On this example, the variable is on the bottom, so that means we're not going to multiply. We're going to divide because it's on the bottom. The 5 from the fraction is still going to go in the front. The sine of 43 still goes at the end, but this time we're going to put division instead of multiplication because the c was on the bottom. 7.3. Last part says use a calculator to approximate the value for 4 decimal places. This is mostly just to make sure that you can round to 4 decimal places because the calculator is doing all the real hard work for you. So the sine of 43, that rounds down to 0.6820 because that 9 makes that 9 go up, but after 9 comes 10, so that makes the 1 become a 2. So you're going to get 0.6820. For the sine of 15, calculator says you're going to go 1, 2, 3, 4 spaces. That 1 does not change it, so it stays 0.2588. Sine of 72, calculator says 0.951056516. 1, 2, 3, 4 spaces. That 5 makes it go up, so it ends up being 0.9511. On number 10, sine of 90 is 1. You don't have to round that one. So we're also going to be doing cosine. Once again, we have this up here. I highly recommend when you're doing trig functions, you always write SOHCAHTOA down. So remember that it's SOH for opposite and hypotenuse. It's CAH, adjacent and hypotenuse. And it's TOA, opposite over adjacent. For the cosine ratios, the adjacent side from A is going to be your letter B, and your hypotenuse is going to be C. From cosine of B, now you're looking over here, your adjacent is going to be A, your hypotenuse is going to be C. It says find the cosine of A. So for the cosine of A, you'd go, okay, adjacent is 8, hypotenuse is 10. So for the cosine of A, the adjacent is 8, the hypotenuse is 10. You have to reduce your fractions. 8 over 10 becomes 4 over 5. And if you put it in the calculator, the decimal is going to be 0.8. When you're doing the cosine of B, now we're looking from this angle. Now your adjacent is 6, hypotenuse is still 10. Reduce that fraction. 6 over 10 becomes 3 over 5. And if you put it in the calculator, you get 0.6. Number 2, cosine of A is going to be 20 over 29. That doesn't reduce, so it stays 20 over 29. In the calculator, you get 0.6897. And for the cosine of B, your adjacent is 21, your hypotenuse is 29. That doesn't reduce. In the calculator, you get 0.7241. And this last one, if I'm doing the cosine of A, I would go adjacent over hypotenuse, the square root of 2 over 2, which doesn't reduce. And then I put it in my calculator, square root of 2 divided by 2. I get 0.7071. And then when I do the cosine of B, now I'm going from here, my adjacent is this square root of 2, my hypotenuse is 2. again, it doesn't reduce. So when you write that in the calculator, you're going to get 0.7071, just like the cosine of A was. Number 4 says find the missing length. Again, the most important part. This is where you would actually use sine, cosine, or tangent if you were outside of a math classroom and you had to do this for a job. From here, from this angle 34, you'd go, okay, that A is adjacent and that 7 is hypotenuse. And adjacent and hypotenuse was only used for cosine. That's how you pick which one you're using, sine, cosine, or tangent. So you go, okay, I'm using cosine. The angle always goes next to it. And then cosine says adjacent goes on top and hypotenuse goes down to the bottom. Just like before, since the variable is on top, you're going to multiply. You're going to write 7 first, cosine of 34 at the end, and then it's multiply here because the A was on the top. Put it in the calculator, 7 times cosine 34, and it gives you the answer. So that's 5.8. Next one, you'd go from this angle. B is your adjacent, 12 is your hypotenuse. Because it's adjacent and hypotenuse, that's why we're using cosine. Angle always goes next to that. Cosine says adjacent goes to the top and hypotenuse goes down to the bottom. Once again, variable's on top, so you're multiplying it. The number from the fraction goes first. Cosine with its angle goes next. Since this was on top, there's a multiply sign in between them. You put it into your calculator, and you get 5.1. Next example, from the 43, this is your adjacent, this is your hypotenuse. Adjacent and hypotenuse is why we're doing cosine. And then the angle is going to go next to it. Adjacent is going to go to the top. Hypotenuse is going to go down to the bottom. This time, the variable is on the bottom, so that means you're going to divide. You're still going to put the number first from the fraction. You're going to put the cosine of 43 at the end, just like before. But right here, you're going to change it to a division sign. 5 divided by the cosine of 43. And you get 6.8. Rounding to 4 decimal places, so the cosine of 43, cosine 43 is 0.7314. Cosine of 15 is 0.9659. Cosine of 72 is 0.3090. And then the cosine of 90 is 0.